Hello friends, welcome to Civil Engineering exam. Today we are going to see the problem related with mechanics of solids in the topic of bending moment and shear force diagram. So the problem is, draw the shear force and bending moment diagram for the simply supported beam. So the simply supported beam is given. So the A and B is the simply supported and having the 2 point loads, that is for 80 kilonewton and 40 kilonewton. So the 80 kilonewton is located 5 meter away from the A support and 40 km is located 7.5 meter away from the A support. Okay, so next thing is 10 kilonewton per meter UDL is acting on the 5 meter span. So then in the end D and E there is a UDL of 16 kilonewton per meter. Okay, so the 2.5 meter distance the UDL 16 kilonewton per meter is acting. Okay, so now we have to find out the bending moment and shear force diagram. Before that we have to find out the reactions, that is RA and RE. Okay, so now we can take the sum of upward force equal to sum of downward force. So sum of upward force equal to RA plus RE. Say then downward force is the UDL, then 10 into 5 again plus 80 kilonewton plus 40 kilonewton plus 16 into 2.5. Okay, so the UDL we can take the kilonewton per meter. So per meter length, so there is a load intensity of 10 kilonewton. Okay, so now we have to multiply the distance. So now RA plus RE equal to RA plus RE equal to the total is 210. Okay, so now we can take the moment about A. So the moment about A, the RA will be the 0. The moment about A. So now RE into the total distance. So the total distance is 15 meter. So RE into 15. Okay, so this is the anti-clockwise force. Okay, so minus RE into 15. About A, RE is anti-clockwise. So then another all the things are clockwise force. Okay, so now plus 16 into distance, that is 2.5 into distance by 2, that is, so the distance is, here we can add this distance into distance by 2. Okay, so now we can add 12.5 plus distance by 2, that is 2.5 divided by 2. Okay, so next thing is again plus 40 into the distance is 7.5. Okay, so then positive value, that is 80 into 5 meter. So then plus 10 into 5 into 5 by 2. Okay, so the distance, the load into distance by 2. So here we can take load into distance by 2 is this distance by 2 plus the remaining distance. Okay, so now we have to add this distance. Okay, so now solve equal to 0. So now solving this, RE equal to, the only unknown is RE. So we have the value of 91.66 kilonewton. So RE value is 91.66 kilonewton. Okay, so now we can substitute the RE value over here. So now we can get the RA value. So the RA equal to 210 minus 91.66. So now RA value is 118.33 kilonewton. So now we found out the RA and RE value, that is reactions. So now RA is here, RA is 118.33, then RE is 91.66. Okay, so now we can easily find out the shear force diagram and shear force diagram. So now here we can take A at the left side. Okay, so A left side there is no force over here. Okay, so now we can take the here as 0. Okay, next thing is we can take A at the right side. So right side we having the RA value, that is a 1 point load is acting. So the force is acting. This force is in the clockwise force. Okay, so about this point, so this is the clockwise force. So now we can take positive 118.33. Okay, so next thing is we can take the B. So B left side there is a force that is a 10 into 5. So the 50 kilonewton is acting. So the about this point the force is acting the anti-clockwise force. So we can minus. So now 118.33 minus 50. Okay, so now we got the value of 68.33. Okay, so the positive 68.33. So next thing is we can take the B at the right side. We having the force of 80 kilonewton, that is the also the anti-clockwise force. Okay, so about this point, so this will act as a anti-clockwise, so we have to put minus. So now here we having the 68.33 minus 50, we got the value of 11.67. okay, minus 11.67. okay, so next thing is we can take the C at the left side. So there is no forces in between the 80 kilonewton and 40 kilonewton. So this 11.67 is maintained till the C distance. Okay, C left side distance. Now we can take the C right side. So C right side we having the anti-clockwise force, that is 40 kilonewton. So now again we having the minus 11.67, again minus 50, that is 51.67. okay, so minus 51.67. okay, so now next thing is we can take the D distance. So from the D we having the no forces over here. So now we can take D till D, that is 51.67. okay, so next thing is we can take the R E at the left side. So E left side we having the force of 16 kilonewton per meter. So now we can take 16 into 2.5. about this point this force also acting anti-clockwise. So now we can get the value of, so that is minus 51.67 into 16 into 2.5. so we having the value of minus 91.67. so now minus 91.67. okay, next thing is we can take the E at right side. So E right side there is a clockwise force over here. The clockwise force is 91.67. okay, so now minus 91.67 again plus 91.67, that will be 0. okay, so here is a 0. okay, so this is the positive bending moment, so positive shear force. Here is a negative shear force. okay, so this is a shear force diagram. So likewise we can find out the bending moment and draw the bending moment diagram. okay, so in the bending moment, we don't want to take the A right side or left side or something. So now we can take the simply A point. Okay. So the A point, there is no forces over here. So in the point load is acting. So we can multiply it by the distance. There is 0 distance. So now the at the support we having the bending moment of 0. Okay. So next thing is we can take the B distance. Okay. So from the B point. So B point we have to find out the bending moment. So the B point, the bending moment is, so there is a reactions, that is the clockwise force, that is 118.33 into 5 meter distance. okay, this is a positive force. Again minus, so there is an anti-clockwise force, that is 10 into 5 into distance divided by 2. okay, so now we got the value of positive 466.83. okay, so now we got the value of 466.83. okay, so next thing is in the B there is no forces. okay, next thing is at C. So at C we having the force will be 118.33 into the total distance is 7.5, that is 7.5. this is a clockwise force. again minus 10 into 5 into distance by 2, that is 5 by 2 plus 2.5. okay, so this is a 2.5 distance. again minus 80 kilonewton into 2.5. so solving this we got the value of 437.47. okay, so now at the C point we having the force of 4 37.47. Okay, so next thing is we can take the point D. For point D, we can take the reaction 118.33 into the total distance. D distance is 12.5, so 12.5. So this is a positive force. Again minus anti-clockwise force is 10 into 5 into distance by 2, that is 5 by 2 plus 7.5. Okay, again minus we having the 80 kilonewton into the total distance is 7.5, again minus 40 into 5 meter. Okay, so now solving this we got the value of 79.125, so that is 179.125. so now we got having the value of 179.125. so next thing is here the value will be 0. Okay, so now how we can find out the 0 over here? So now we can take 118.33 into the total distance. So the total distance is 15. Okay, so this is the only positive force. Okay, so next thing is negative force, that is 10 into 5 meter into distance by 2, that is 5 by 2, again plus that is 10. Okay, so again minus 80 kilonewton, so 80 kilonewton point load into 10 meter, so that distance is 10 meter, again minus 40 kilonewton into 7.5 meter, again minus we have in the force of 16 kilonewton into 2.5 into 2.5 divided by 2. Okay, so now we got the value of 0. Okay, so this is the positive bending moment. Okay, so this is the method we can solve the problem. Again we will see next video. Thank you.